Hi, geometry. I hope you guys are doing okay. It's Tuesday, and I finally figured out how to put videos on YouTube. We did a couple of Algebra 1 ones, so you'll see those, but I'm going to do specifically geometry ones for you guys. So if you have a chance to watch it, cool. If you don't, when you get back, you're not responsible for it in these 2 weeks, right? So come, and by these 2 weeks, I mean today is the 17th, which is Tuesday. We are technically still out of school until the 27th without any new assignments. We don't know what's happening yet, and it's an evolving situation. So please feel free to email me if you have questions. But the best place, and let me just share what I'm going to do and how I'm going to do this. The best place always, here's our work, hooray, you're not going to miss it. And now you can watch it as many times as you want to. Fast forward through the parts that you understand, and rewind the parts that you don't. And listen to my lovely voice again, explain it. Just kidding. Okay, anyway, so as of right now, we're still out for 2 weeks. Go here. If you have questions, I know some of you all knew before I did, or the rumor was that we were closing for 2 weeks, but we didn't even know until Governor Hogan said so. So we are, what he's doing, we're following the direction of him right now. So it's still that we're closed until the 27th. You won't have new work assignments until then. If it continues beyond the 27th, chances are that we will have some sort of homeschool situation happening. So these videos will be either done now or later. Also, if some of you are typically getting school lunches and you're not getting them right now, well, you can. There's different locations. I have to download this and post it, but it says children up to 18 years old, but I did get an email from Ms. Charlie Green that says that any student, so if you're 19, you're 20, that's okay. Go get your food, please. We want you to eat because you can't think without eating. And you can go to any of the schools. So if you have your ID, definitely bring that with you. I don't know how strict they are going to be about it, but it's always good to have that ID with you. So all these schools have lunches, and starting today, I believe they'll have breakfast as well. It's Tuesday, the 17th. Okay. It'll be like a chronological. You'll see how things go and how they develop and how I talk. Chances are my children will just pop in these videos. Sorry. Mo Willems, the guy that wrote, Don't Let the Pigeon Drive the Bus. He's on YouTube right now teaching my kid how to draw because that's where we are. All right. At first, I was going to redo everything. Because it may not make a whole lot of sense or whatever it may be, but then I was thinking that's a lot of videos and we've already done this, so let's jump down. This is from my period 4 folder, so I can share it to period 6 as well. But I'm going to go through the stuff that I'm going to try to keep these videos like 10 minutes so that it's not too long, but a couple of things, a couple of topics, and then you can watch whenever makes sense for you. I'm sorry, there's loud background. I don't know why people drive such loud vehicles. All right, so Yasmin and Brianna are geometry students who each make a mistake in calculating how to fill glass tube half full. And you're like, oh, that's cool. I don't remember glass tube being half full. Here it is. Remember, we did this before. Maybe we should do it again so that it is. Yep. So we do it SLT 12. We're on page 5. I'll zoom in as we're doing things, but let's go through that again. And if you're like, I got it the first time, it's over, fast forward button, okay? I'm going to erase all this. Oh, can I? Because it wasn't here. I can't actually erase it. Okay, so we had to figure out what half full was. So just to go through it, half full on this first glass is obviously, well, it was squared up. And hold on, I'm going to pause this loudness. So let me pause the recording for a quick second. Oops, I was recording. I did record videos without recording. That was funny. All right, hold on 1 second. See, didn't even know I was gone. Okay, so let me share this again. We figured out that the bottom was 56.5, and we had done that previously, right? This is math, it builds on itself. when we were finding the volume of this, we had to find the volume of the hemisphere and then add that to the volume of the cylinder. Sorry, just ate some peanut butter crackers and apparently it is making me do that. Okay, so we had figured out that this was 56.5, and then we wanted to get it half full, so we knew the whole thing was 70. That's what I'm reading. So we need 14.5 more cubic centimeters so that it would be half full, or 69, 170, whole thing. Yeah, the glass altogether is 141.3. I guess we rounded it to 70. Good for us. It's fine. And then found that it would need to be the height of the water would need to be 3.5 centimeters, right? Okay, so they made a mistake. Here's Jasmine. Jasmine, guys, I am doing my Rosetta Stone. I'm only 3 lessons in, but who knows? Maybe I will be fluent when we get back. All right, tell how you figured it out. So she got 3 centimeters. So what did she do? Some of you may already have an idea of what she did. Well, what she wrote is you divide the final volume of the glass in half. The height of the glass is when it is full is 6 centimeters. When is half full, the height will be half, which is 3 centimeters. So she was, what'd she do? Pause the video and discuss it with a friend. She was thinking of like glass 1, right? Straight sides down. So that means that she doesn't have to worry about this little curve, right? We drew a picture here to show that this curve has volume, right? Where it would be, it would look, oh, I can get that thing out, but it would almost look like a stadium, right? Of space. Totally makes sense to me. Why does it make sense? Just kidding. That was a really weird reference, but I see it in my brain, right? What I see is I see a circle and I see it coming up on the sides and all of that, like around, like, you know, when you're playing in the sand and you push like a ball in the sand and it like makes that indent, that's what's taken out of here, right? It's like the side things. I'm just gonna move on because it makes sense in here, but it might not be as I'm saying it. If you have questions, email me. So she was wrong because she assumed that it was like the cylinder, and it's not like the cylinder. So they're gonna tell us why. Yeah, describe how they need to change their thinking. Jasmine did not consider that the bottom half of the glass is the hemisphere, right? So it's not going to have the same amount of like volume as the cylinder. All right, so what this person, what Brianna did, is she said 14.3 centimeters, which is interesting, and she did tell you how you figured it out. She took the 141 divided by 2 and got 17.65. Then subtracted half of it, which is 14.13. So what was her misconception? Pause the video and figure it out. Just kidding. So she did half and she figured that out. And we got to that point here as well, right? We said 14.15, which is fine. I know that we did some estimation on it. That's okay. 14.15. She got 14.13, but then didn't consider, you know, that is the volume that that's the volume. So that's 3-dimensional. That's the volume that she needed for it to be half full, and she made it into the 1-dimensional height, right? So that's where she made her mistake there. All right, so, and we started this one. Maybe we'll just do through this one, and I can't erase this terrible handwriting. Remember my pen on the board was being all crazy. So, and I can't erase it now because that's how Cami works. Like, if I write something on there, you can't erase it, but I can. But I'm home, I guess. I should be logged into the right one. Maybe that's why. Pause the share for a second so you can't really see. This is my, yeah. Okay. That's why I need to log in with my school one. So once I do that, then I can erase it, I think. I should be able to. Let's do weird stuff. So, how are you all doing as I find this? I could pause the video, or you could fast forward. Both of those things work equally well, but I'm almost there, almost there. Okay, so here it is, it's coming. I can reshare it with you. You're like, wow, it doesn't look any different. I know, but now, because I'm back signed into the right account, now I can erase this. All right, we'll do this one, SLT 13, this one page, and then I'll end this video so that it's not too much. Do a couple pages for every video. Keep it as short as possible, and I am long-winded. You know that. Okay. So someone came up with a great idea, and I don't know if she wants her name on YouTube, but she came up with a great idea in class. And I went with it because I'm not mad about it. So a golf ball has a diameter of 1.68 inches and can be packed into two different ways, shown above. The cylindrical package has a volume of 11.361 inches cubed, or cubic inches, and a diameter of 1.6875 inches. And the rectangular prism has this base. I'm not going to do it again. If these two packages are the same height, find the volume of the rectangular prism package. Now, what she said, and I loved it, was that that obviously in this package it's 3 balls high, right? So since it's 3 balls high, she multiplied the 1.68 times 3 to get an approximate height. And you know what? I'm not mad at it. You can do that. I would give you credit for it. I think it's a very creative idea. I'm going to do it a different way. Because there's a chance that there's a little space, right, like on the top. You know, it's not like ball is going to touch the bottom and the top. Usually there's a little bit of space. So we are going to be a little bit specific about it. But did it that way. That very smart young lady did it. More power to you. I'm just going to do it this way. Okay, so I do know that the volume is the volume of the cylinder is 11.361 centimeters cubed. I also know that volume is always done as area of the base, big B, times height, where your base is the area of your base shape. Sorry, I was just thinking of something else at the same time. All right, well, it did tell us that this is our diameter. Oops, handwriting will get neat one day. So this is the diameter of that spot. Okay, so the area of the base, and I have to remember, is pi r squared, because the base of a cylinder is a circle. So I'm going to plug in all the things that I know and figure out the thing that I don't. So 11.361 is going to equal to pi r squared. Well, what's r? Well, I know diameter is this, so r is half of that, and I could always do that math another way, or there we go, we have a lovely calculator. Okay, so it is, and I don't want to say that it's wrong, so oops, that's the wrong one. That was the one I had before. We have 1.6875. So 1.6875 divided by 2. That'll give me my radius. So 84.375. So 80.84. Oops, already forgot. So put the point of it. 84375. 84375 squared times my height, right? And that's what I don't know. That's what I want to figure out. So how would I do this? Pause the video. No, I'm just kidding. I'll stop saying it. Okay. To get h by itself, I'm going to divide by this whole thing, right? Like, don't do 3.14 yet. Keep it as pi. Don't do 0.84375 squared. Don't estimate what that is. Put the whole mess into your calculator, all right? Now, it's good to have an idea and say that this is about 3.5. This squared, well, it's going to be less than 1, right? So this is dividing by less than 3, so I should get a number that is, 11 divided by 3, so I should get 3 something. That's just an idea as we're doing it. Okay, So I already forgot because I'm talking too much. 11.361. So 11.361 divided by, I'm going to do pi times r squared. Well, there's my r right there, so I don't have to worry about it. But I am going to put it in parentheses just so I know I want to do that first. 375 squared. So I was wrong. Yeah, well, 3 is close, yeah. But I know that that's right. It's not in like, I wasn't in like left field, right? So I said 3-ish, it's 5, that's okay. But you want to have that 5.808, I would probably say, estimate it to that 100th. So my height is going to be 5.08. Ooh, but that's okay. And then, so that's the height of this package. If I know that this is 5.08, and I know that my base, so this is 5.08, my base is going to be, it's a square, 1.6875, right? And this is the same. So now I can figure out the area there. Finding out the area of a, well, prism, a rectangular prism. This is technically, well, the square. Doesn't matter, still rectangle. You do your sides squared times your height, and that's going to give you your volume, because again, this is volume equals big BH. The big B is the side squared. So throw it on the calculator because they're lovely. Okay, there's a number there, 1.6875 squared, right, times my height, which is right above it, 5.08. Now, if you really want to be special and you're using a calculator, using a computer, so this is 14.47. If I plug it here, it's 14.47, still the same thing. So, you know, it is going to be an estimate. So having the most numbers you can for the estimate, especially when you're not actually doing the math the calculator is, you throw it in there. So 14.47 is going to be the volume of the rectangular prism. So B equals 14.47 inches cubed, because it's 3-dimensional. All right. So that's that one. Let's make sure that we answered the question. If these two packages are the same height, find the volume of the rectangular prism. Here it is. So you can see that they used a lot less volume in the cylinder, and you can maybe think about why that would be. All right. If each package holds 3 standard size golf balls, how much unused space is there in the package? Woo, look at that. So 3 standard size golf balls. What do we know about standard size golf balls? The golf ball has a diameter of 1.68 inches. Okay, so we'll have to find the volume of a ball first. And you can always look that up. And I don't want to around. Blue, it's nice and refreshing, I guess. Okay, so the volume of a cylinder, you can always look this up, 4/3 pi r cubed. Oh, my daughter is not taking a nap like I thought she would. And they give us the diameter as opposed to the radius, but 1.68 divided by 2, so 1.68 divided by 2 is 0.84. Now you could do that in your head. And I could, but I don't want to embarrass myself. This is getting recorded. All right, so volume equals 4/3 pi times 0.84 cubed. All right, so I can do 4/3 times pi times r cubed. Well, we have 0.84 to the 3rd power. All right, now if you're like, oh, I want to make sure that that's in, you know, that was done first, because that's supposed to be, yes, you're going to do your order of operations. That's going to happen. It's not going to change it, because whenever you put an exponent, it only does the number right in front. So something like if it was written like x, y cubed, the cube only goes to the y unless there's parentheses around it. But, you know, you never want to get something wrong because you typed something calculated. So feel free to always throw it in there. So the answer is 2.48. That's what I would go with. So the volume is 2.48, right? For one ball. And you want to know what it is for 3 balls, right? Well, again, if you're using the calculator, pi is irrational. It's going to go on forever, but they're figuring, well, like it can keep a lot more spaces, a lot more place values in it than I can in my brain. So what I could do instead of, you know, doing, well, I'll show you the difference between the two. So I could just multiply this times 3 because there's 3 balls and I'm going to get 7.45. So for 3 balls, volume of 3 balls, it's just the notation that's going to keep in my head right now, is 7.44. Yeah. 7 point, and I'm saying it as I'm saying 45. We're going to do 7 times 4.45. Now, conversely, had you just put in the calculator, had you left this out with just that and done 2.48 times 3, it's 7.44, and you're like, Miss Elmer, it's 100th off. I know, but that 100th, if it was money and it was talking about $1 million and you're spreading it, you want more of it. So very close, but that's why keeping it in the calculator is helpful. All right, so that's a volume of the balls. So the unused space. So I'm going to say, okay, I'm going to separate into 2. So for the cylinder, right, the volume is, for the package, is 11.361. 11.361. And for the rectangle, angular prism, that was 14.47. All right, volume equals 14.47. I'm going to say BC and BR. Why not? Just to keep them straight. Okay. So what do you think I would do to figure out how much extra space is left over, or what is left over? And hopefully when you hear left over, you think of you're taking away, right? Subtraction. So I'm going to take away the volume here, which is a 7.45, and see what I get. Same thing here, 7.45. And I could do that 7.02. Holy moly, that's a lot of extra space. Okay, and then this one, I should just subtract. Let me stop showing you bad behaviors of doing it. Yes, I'm going to regroup. Yes, I'm going to do 13, so I'm going to do 9, and then 10 minus 7 is 3. Okay, so centimeters cubed. How much unused space? This is unused space, right? And that is for the cylinder. And you know, you could make it nice and say, you write it all out. So the volume of unused space for the cylinder is 3.911 cubic inches, not centimeters. I mean, yeah, sorry, I just switched. Because we should use the metric system. Inches, inches, inches. Okay. So that's that on that one. I'll stop there for right now because this video is already too long. But that is how you do your golf ball problem. I'll be back in a little bit to do the other problems. Please email me with questions. Hope you're doing all right. Miss you guys. Bye.